No.
This experiment we are going to calculate the linear density of the string. This formula will be given to you. Mu is equal to tau over V is equal to tau over mu. This formula will be given. I have to calculate mu. V square is equal to tau over. You are going to construct the standing waves on the string. For the wave, V is equal to F lambda, you know that. V is the velocity and F is the frequency, lambda is the wave. Since you are constructing the standing wave on this, you know the relations for standing wave. The L is the length of the rope. Length of the rope is equal to N lambda over 2. I am telling how to get the formula. If you don't remember the final formula, you can derive the formula from this. This no need to write on the paper. Okay. From this, lambda is equal to 2L over N. Now write this. V is equal to F 2L over N. See square. Let me get square for this. V square is equal to F square L square 4 over N square. This formula, the left hand sides are the same. Therefore, right hand side should be equal. Sigma tau over mu, number of loops. N equal to 4. If N equal to 4, this is 4 square. 4 square, 4 get cancelled. What I have, rearranging this, mu is equal to, okay. And this is also equal to mg. The tension in the rope is equal to m into g. So, this is 4 mg divided by F square L square. So, I am going to divide into two parts, the constant part and variable. 4g by L square is equal to m by F square. This is the final formula to calculate the linear density of the string. G is the gravity, you know it. Length. L is the length. The length of the rope starts from here to this, the center of the pulley. Whatever the length is printed on the paper, you have to fix it. Suppose if I say 1.3 meter, we have to fix 1.3 meter from here to here, right? 1.1, 1.11 is 1. Read the paper and fix the length. Then I'm going to take the reading. This is M. The load the rope according to the mass given here. Right? Whatever the mass given, load that mass. Once the length is fixed, the mass is loaded and switch on this. I'm going to adjust the frequency of the wave so that the 4 well-defined loop is produced on the string. Please maintain the social distance. Arba kamsa? Arba.
4. 4.
Yes. Adjust this so that I am getting a biggest loop. Write this frequency here. Right? Copy the frequency for this mass. Then change the mass according to the value given here. Change the mass, the loop will disappear. Again adjust the frequency so that you are getting 4 well-defined loop. Write the frequency. Continue the experiment until the last mass given in the schedule. Is it clear?
It should be 4 loops.
4 loops. N equal to 4. Now you have F. Can you square it? F square. F square will be a big number. So in order to draw the graph easily, then I am maintaining like this, 10 to the power something. See, 10 to the power of 3 is a common. I am going to draw graph only for the number and keep the 10 to the power as a unit. I am going to draw the graph between F square versus M. F square here. 10 to the power of 3, second to the power of minus 2. I'm taking it as a unit. And m kilogram. A straight line. Your slope is equal to, y2 minus y1 divided by x2 minus x1. The unit of the slope, 10 to the power 3, second to the power minus 2 divided by kilogram. Can you get the slope in SI unit? Now, next is, I'm going to calculate your mu. How to get it? The meaning of the slope. F square versus m, y divided by x. Now come to this. M by f square, this is f square over m, is equal to 1 over slope. Mu is equal to 4g by L square into 1 over slope. G, you know it, right? L is the length, 1.1, 1.2, whatever the length, you have to write it here. And the slope, substitute the slope, you will get the linear density of the string. Any doubt? The major source of error in this experiment is the length of the rope and the resonant frequency. We are fixing length, we are fixing the resonant frequency. Don't say just L. L means length of the rope. The L for that experiment is different, L for that experiment is different. You have to specify what is L. Here the L means the length of the rope. And the F is the resonant frequency. And both could be major source of error. There is that, yes. The L and the F. The G cannot be the source of error. 4 cannot be the source of error. The M could be the source of error. What is M? M is this. Whatever the mass printed there, I am taking it. If there is any error, and that could be the minor source of error. We are not the responsible for that. Therefore, we are taking as a minor source. The minor source of error is the mass. Any doubt in this?
Teacher, in the formula, can I write the final formula?
Yes. If you forget, I'm teaching you how to bring it.
Yes.
I never remember the final formula.
Yes.
The formula, the first
Which
formula
paper is this?
will be given.
Not final formula.
No,
The initial formula will be given. Here, this formula will be given to you. Sorry, this formula will be given to you. Your x is equal to Vn by 2f. What is that? Okay. X is equal to Vn by 2f. This formula will be given. I'm going to calculate the speed of the sound in the air. So V is equal to 2fx over n. F is the frequency of the wave, frequency of the sound wave. X is the length of the resonance cavity or the length of the standing wave. And n is the harmonic number. The n can take value 1, 2, 3, 4, 5, 6 and so on. Now how you are going to perform? You are going to do only one frequency. See, the frequency is given here. I'm going to set the frequency here. Suppose if I say 1.3 kilohertz. 1.3 kilohertz, you know how to use this. 1.3 kilohertz. Whatever the printed value, I have to fix the value. The next I'm going to give 1. The voltage 1, then only the sound will be produced. Now I produce the sound. Switch on this. You get the waveform, right? I think there is some mushkil. The battery, I will today after the class I will go and purchase the battery for this. Now this is growing, right? This is growing. When you get the biggest size, see, when the size is biggest, you stop it. When the size is biggest, you stop it and you can take the X.
how many loops should be?
ما له علاقة.
There is no loop here.
ما تحتاج اللوب.
When you get the bigger size, you stop moving.
تاخذ أكبر موجة ممكن.
Without this also I can take the reading, right? Now I got the first one. I can take the X for n equal to 1. Pull this continuously. Without seeing this I can take. The sound disappears. The sound disappears.
تبدا طول جديد.
Pulling continues now. Sound slowly increasing.
اتمنى اني افدتكم يعني.
Yes. Here I'm getting the maximum. Right? When the size is maximum, stop moving. Can you take this? This is x for second, third x, fourth x, fifth x, and so on. You are going to draw the graph between x versus n. X versus n. X centimeter, n no unit. And get the graph. Your slope, the slope, you know how to calculate it? Unit. The unit is centimeter down no unit, x no unit. This is in centimeter. You know how to convert it? Into 10 to the power minus 2 meter. Now I converted slope into SI unit. What is the meaning of the slope? The slope is equal to x over n. Wherever the x and n is there, you can replace that. This is x over n is equal to slope, where v is equal to 2f into slope. What is f? F is the frequency 1.3 kilohertz or 1.4 kilohertz, whatever the value you are fixing. And slope, substitute the slope here, you will calculate the speed of the sound in the air, meter per second. The major source of error, we are having three quantities only, f, x and n. N cannot be major source of error, sorry, any source of error. The n is the number 1, 2, 3. The source of error could be f and x. The x we are measuring, right? What is x? X is the length of the standing wave or length of the resonance cavity. The x could be the major source of error in this experiment. F we are fixing from the instrument. The frequency is the minor source of error. Frequency of the sound is the minor source of error in this experiment. Any doubt in this? PV is equal to nRT, universal gas constant. For Charles' law, you are increasing the pressure, the temperature and finding the change in the volume. The pressure is constant. P delta V is equal to nR delta T. I'm going to get the number of moles of gases in the container. P over R delta V by delta T. This is the formula I'm going to calculate the number of moles of gases in the container. And come to the experiment. When you come to this place, the water will be here. You have to measure the temperature of water by using this, that is TB, right? And TW is this. TW, the temperature in this, temperature of the water. First, you should keep this inside this for 1 minute. After 1 minute, take it out and connect this. And check this. It is going back. The correction is perfect. Suppose if I written 30 degrees, the TW is 30 degrees is printed on this. Switch on this, it is heating. 30 degrees, 1 degree less than that, 29. When you see 29 here, put this inside the water. Except the rubber part, the rest should be inside the water. Now continuously look at this. When it touches 30 exactly, and see how much distance the piston pushed up. The bottom of the piston, you have to say this is in millimeter. That is your L. Clear? Once you finish this, you can switch off this, again detach this and put it here for a minute. And after a minute, again do this the same. And press this back to 0. Check it. Okay. The next is 35. Start this is continuously rising. Initially 30, slowly it is rising. 1 degree less, 34, put it here. By the time it reaches 35, note how much distance it traveled. Clear? Continue this experiment. Come to this. Delta T. Delta T is equal to TW minus TB. This is TW, this is TB. You can calculate delta T. Delta T in Kelvin or Celsius, it will be the same. It will be the same meaning because the difference in temperature. And L is in millimeter. I want to calculate delta L. Delta L equal to L minus L0. L0 initial length equal to 0. So this I am expressing in terms of meter. Convert millimeter into meter. The delta V. How to get delta V? The delta V is equal to pi r square into delta L. R is the radius of the piston. This will be printed on the paper. What is the radius of the piston? That is given in a millimeter. You have to convert into meter. And delta L, this is delta L. Can you get the volume here? Delta V, the change in the volume, you can fill it here. And see, the volume is a different number, 10 to the power of minus 6. Maintain the uniform power throughout this. So you can keep the power as the unit. And plot the graph delta V versus delta T. Delta V, I am going to take it here, 10 to the power minus 6 meter cube, I am taking as the unit. This is delta T. Delta T, Kelvin or degree Celsius, you can take, both are the same. And get the slope. Your slope is equal to some number, the unit. 10 to the power of minus 6 meter cube by Kelvin. Now you got the SI unit, the slope in SI unit. The next step is to calculate the number of moles of gases. What is the meaning of slope? The slope is equal to delta V by delta T, Y quantity by X quantity. Now see here, delta V by delta T by delta T is equal to slope. N equal to P over R into slope. What is P? P is the pressure. It will be printed on your paper. R is the universal gas constant. It the value also printed on the paper. Just to calculate the slope, multiply with this. Can you calculate the number of moles of gases? The N is equal to, the unit is mole. Here the major source of error. What is the major source of error? The delta V. The delta V could be the major source of error. What is delta V? The change in the volume of the piston. And delta T is also major source of error, because we are measuring TB and TW. Delta T is also major source of error. The R cannot be the source of error, it is a constant. The P could be minor source of error. What is P? P is the pressure at the room temperature, pressure of the air in the room. The P could be the minor source of error in this experiment. Any other doubt?
How much time we need to get the numbers?
Who's paper this? How much time?
We need to get the numbers.
Yes.
كل شيء 50 دقيقة 15.
بيقول 50 دقيقة بس 50 دقيقة في اليوم كله.
The resistivity. There are two parts. This part I will give you directly the value. Resistivity I will give you directly. Don't do this one. You are going to do one like this.
Okay.
Right?
Graph, doctor, already.
This we have to do. This will take 2 minutes. Right? Now the value is printed here. You have to write this value. Whatever the value. If I change the value, you would write this. 10, 20, 30, 40, 50 and so on. You are going to fill this. This you can finish in 5 minutes. Now keep this. You should not change this position until you finish the experiment. See this, it is 20. Keep this at 20. You are getting some number, right? Write the number with the letter. See 5.85. See the top, you get some letter. What is the letter? M. M means 10 to the power of 6. If I get K, K means 10 to the power of 3. You write the number with the letter. With the letter M, 10 to the power of 6. This is 20. If I ask 30, keep it at 30. It's 6.47 M. 6.47 in 10 to the power of 6. Then you can complete this. Until you finish the experiment, I am not changing this position. This should be the same position. Now you got this. See, the power should be uniform. If it is not uniform, make it uniform. Now I am going to draw the graph. The graph, what is the graph? Plot R versus V. R should go to y-axis. R should go to y-axis. R versus L. R is the unit, 10 to the power of, 6. 6 ohm is the unit. This is millimeter is the unit. I am going to calculate your T. This formula will be given R rho L by A. A is the area of cross section of the pencil line. rho L by W into T. T, I'm going to calculate T is equal to rho L by R W. Rearrange this, rho by W L over R. Rho is the resistivity I will give you directly. W is the width of this line. It's 1 millimeter, 2 millimeter, 3 millimeter, whatever the width, you can write it here. L is the length of the pencil line. R is the resistance. See, I draw the graph, calculate the slope. Now let me calculate the slope. Your slope is equal to some number, write the unit, 10 to the power of 6 ohm by 10 to the power of minus 3 meter. Is a millimeter, I'm changing it to meter. Now simplify this, finally you will get ohm per meter. The slope in ohm per meter. I'm going to substitute the value of the slope. What is the meaning of the slope? The slope is equal to R over L, y by x. L over R. Compare this, T is equal to rho by W into 1 over slope. The rho I will give you directly, the value. And W is the width, is 1 millimeter, 2 millimeter, you have to change into meter. And the slope, write the slope value, you will get the sources of, the thickness of pencil line. Coming to the source of error, out of the 4 quantities, this quantity I am giving you directly rho, so it will not participate in the source of error. The source of error only 3 quantities, L, W and R. The length could be major source of error because we are fixing it. The length is major source of error. What about the W? Width is a major source of error. R, who is measuring R, is measured by the instrument. R could be the minor source of error. The length of the pencil line, W width of the pencil line could be major source of error, and the resistance of the pencil line could be minor source of error in this experiment. The time is not enough, therefore I reduced it into one part. You are going to get the operating temperature. This formula will be given to you, 1 plus alpha T minus T0. So 1 plus alpha T minus T0 is equal to R by R0. R is the resistance at the high temperature, R0 is resistance at the low temperature. T high temperature, T0 low temperature. Alpha T minus T0 is equal to R by R0 minus 1. T minus T0 is equal to 1 over alpha R by R0 minus 1. T is equal to T0 plus 1 by alpha R by R0 minus 1. This is the formula to calculate your T. T0 is the room temperature. T0 is equal to room temperature plus 273. You can write the room temperature. I will give the thermometer. You can measure the room temperature and add with this. That will be given in Kelvin. The alpha is printed on the paper. You are going to get R and R0 value. See, there are 2 parts in this experiment. You are going to do only one part, only first part. The second part you are not going to do. I will add one more column here. After 1, you directly go to 12. You know how to do this? Switch on this. This is V. This is V. This is I. The V unit is volt. It is not volt. MV. Press this button until you get volt. Volt. And move the point to the center. Now fix the voltage as mentioned here and write the current. What is the first voltage? 0.3. Can I fix the 0.3 here by adjusting this? .3. What is the current? 0.28. Can you write it here? And change the voltage according to this, 0.4, 0.5. I will give only 5 data, not many data. This is 10 data. In exam, I will give you only 5 data. Now, after 1, jump to 12 and keep this 12 volt here and then write the current. Can you calculate the resistance? The resistance is equal to V over I. You can calculate it. The last value is R12. The last value This is R12, you can take it. You are going to draw the graph only for this part. So the graph is drawn between R versus L. The graph is R home, V volt. And better to start the graph with 0 for this graph, because we are going to get the intercept. You will get a straight line like this. The line starts from here. What do? Extend the line using the ruler, same straight line. This part is called as R0. What is the meaning of that? What is the voltage here? 0. If you apply the 0 voltage, there is no heat generated in the filament. No heat generated means the temperature is room temperature. When the temperature is room temperature, resistance of the element is R0. You can get R0 from this, and R12 you can pick directly from the schedule. Substitute all these values, you will get the operating temperature in Kelvin. The major and minor source of error. Say this, the alpha is a constant. Alpha is a constant, so that is given. R and R0
R0.
could the major source of error. Instead of that, R and R0 we are not doing directly. How you are getting R and R0? By calculating these two quantities, V and I. The error introduced R is due to measurement of R. We are not measuring R directly. We are measuring V and I. What is the major source of error here? Both. Both we are measuring manually. For the major source of error in this experiment is the potential difference V and the current passing through the filament I. Both could be the major source of error in this experiment. What is the minor? The minor may be the temperature. The room temperature could be the minor source of error in this experiment. Any doubt in this? The input impedance of your voltmeter. For this formula will be given. Exponential minus T by RC. This formula will be given. I want to find R. How to get it? Let us play with this equation. Exponential minus T by RC is equal to V by V0. If I want to remove the exponential, what I should do? Minus T over RC is equal to ln V by V0. Take the minus sign to the other side. By RC is minus ln V by V0. Take the minus sign inside. What happens? T by RC ln V0 by V. Go minus sign inside, it flips. I want to find R. R is equal to T over C 1 over ln V0 over. I'm going to group into the variables and the constant. R is equal to 1 over C T over ln V0 over. This is constant, this is variable. Let me come to this. In the class, you did the 2 capacitance. In the exam, you are going to do only 1 capacitance. Only 1 schedule. Every time I'm telling gentlemen, check that.
He has everything difficult. He has everything difficult.
I don't know. What is that? Okay.
I'm assuming.
We have to fix it. R is equal to 10 kilo ohm. Check this. This is C. Some student play. All the dials should read 0. Except this. 1 into 10, 10 kilo ohm. Check the dial. This one, capacitance. See, what is the value printed here? I will print some value on the question paper. If I say 4 microfarad, keep it 4 microfarad. Other should be 0, 4 microfarad. If I printed 7 microfarad, keep 7. Whatever the value printed here in the schedule, we have to fix that capacitance. Clear? Here in the class, I printed 5 and 10. Whatever the value printed in the question paper, you have to keep that value. After fixing that, switch on this. Turn this on. Put the switch to the on side, and you have to fix 10 volt. The 10 volt, and by adjusting this, you can keep 10 volt. 10 volt. Once I fix 10 volt, see here, it is time, is a voltage. This is a calculation, right? Only these two columns I am going to fill. The time equal to 0, 20, 40 or 0, 30, 60, whatever the value it is printed. When t equal to 0, what is the voltage? It is V0. Right? When t equal to 0, what is the voltage? V0. In the beginning, what is the voltage? That is your V0. Now, turn this off and switch on the timer. Same time. Now the time is running, the whole potential is dropping. Suppose this is 20. When time equal to 20 seconds, what is the potential? Can you write it here? And this should go continuously. You should not stop in between. Right? And time equal to 40 seconds, after this, whatever the printed, you can measure the potential. Once you complete 3 minutes, you can finish this experiment.
Teacher, can I use my phone?
No.
To fix
The phone is not allowed in the exam. According to JUC policies, the phone, you cannot bring the phone for the exam.
Just for review.
Review, today is review. Right? The exam, as per the rules, the phone is not allowed.
With one click, fill the
Yes.
whole.
I should not switch off this in between.
Yes.
If I switch on this, it should work continuously. Now, this is the V0, these are V's. Can I find this? Ln V0 over V, I can calculate these values. I'm going to draw the graph. The graph, ln V0 versus V versus T. Ln V0 over V, there is no unit for this. This is T second. And get the straight line, calculate the slope. Your slope is equal to something. Unit is, no unit for this. 1 divided by S is the unit. And what is the meaning of the slope? Your slope is equal to ln V0 over V divided by T. This is your slope. Now come to this. T over ln V0 over V. This is ln V0 over Vt. This is flips. R is equal to 1 by C into 1 by slope. The C is the capacitance. Suppose if I say 5 microfarad, micro, you have to expand that. 5 into 10 to the power of minus 6. Micro means minus 6. If I put 7 into 10 to the power of minus 6 and write the slope value, you will get the impedance. The ohm is the SI unit of the input impedance. The major and minor source of error. To see that, let us go to this part. The T, yes, it could be the major source of error. The time and the voltage, the potential difference and the time could be the major source of error. What is the minor? C. We are fixing something C from this device. So C could be the minor source of error in this experiment. Any doubt? Yes.